Dia Yeva Kharja. Welcome back, everyone. You're very welcome. There's a new arrival here in the tech shebeen. It's looking a little bit tired and monochrome, but it won't for very long. Although the strong lights of the workshop don't exactly flatter this engine, they do allow us to record some of the finer details before proceeding. Engine builder number 700. Wherever you are now, your work is still good. This engine has been together for almost half a century, so disassembly will require heat, lubrication and gentle persuasion. Differential heat expansion gently separates the two metals that are in contact, allowing the fluid to penetrate deeper, making the bolt more compliant. This dramatically reduces the chances of stripping or shearing screws and bolts. This technique always works for me. It requires patience but is less stressful on machinery. I restore by repair, but these heat control boxes and heating tubes are beyond help. I'll change these for a nice modern reproduction, all the way from Germany. Oops, I don't want to spoil the next episode. This preheater seal is a quality natural rubber component. Once upon a time, this material literally came from a tree. That's why it's lasted for half a century. This will be renovated and reused. The preheater duct is the only piece of tinware that was not originally painted in gloss black, presumably for heat management. I'll get this colour matched for repainting later. The seal is also made from natural rubber, so will be renovated and put back in place. A watchmaker's screwdriver is a useful tool for unpicking block connectors. While the engine is nice and stable on the buggy, I'll loosen all the tight fastenings before transferring it onto an engine stand later. No matter how conscientious you are, you're guaranteed to always miss one screw. This may be a low mileage engine, but a half-century build-up of oily dust is reducing cooling efficiency. Clearly it's worth inspecting these motors at least twice a century. I like that clean little dink sound made by a fastener that's been removed for the first time in a long time. It's the sound of mechanical archaeology. The fan pulley is bolted to the cooling fan by 4 number 8 XZN fasteners, sometimes called triple square bolts. These lesser used tools are needed. Like a door in a haunted castle. One for my friend the vapor blaster, another for my friend the powder coater. This rumble tells me our alternator has one or more failed bearings. There's another surprise for the list of unexpected repair jobs. The deeper we get into the engine, the bigger and oilier the fasteners get. Things tend to progress more quickly. That said, when removing any old bolt or nut, a single hex socket is preferable as it spreads the torque more evenly to the fastener than a multi-hex socket does. The proof that a Type 4 engine alternator can be removed with the heat exchanger still in place. But why would you do it this way? It's a pain in the... To remove the clutch and flywheel, the flywheel needs to be locked in place with a dog. Otherwise we'll just end up turning over the engine. The clutch is retained by 6 number 8 XZN fasteners. Five self-locking bolts retain the flywheel, which in itself is already informing us of another surprise for the list of unexpected repair jobs. This pretty looking pattern tells us we've had an oil leak from the main crankshaft seal. Even if this seal had not failed, I was going to replace it anyway, as this is a sensible job with the engine removed. Time for more of this. After some more cleaning, I found another chalk mark, or factory marking from the time when this engine was being built on the assembly line. I don't really know what the numeral for 2 is supposed to mean, but it's lasted this long, so it's worth preserving. Off with the engine breather. It's reassuringly clean in here, a telltale of good maintenance. A single 13mm nut retains the distributor. I'm removing this now because I have a plan for it in the next episode. No spoilers. Now we're beginning to look like a 70,000 kilometre engine. For my next trick, I'm going to make the engine hover in plein air. Only kidding. I've transferred the engine onto a stand to access the final items underneath. If a stand is not available, these items can also be removed while the engine is still in the vehicle. All of these tinware bolts were removed in one piece. Not one broke off or sheared in place. I cannot take credit for this technique of using a heat gun and penetrating fluid because I stole it from my brother, but it works a charm. The heat exchangers must be removed to allow the fan shroud to be detached. Which means more of this. It really is a remarkable design feature of these engines that the older they get, the more they seem to secrete their very own natural preservative. This really is as much fun as it looks. With the engine stripped back, we can see the cooling fins on the cylinders, reminding us this really is just a big air-cooled engine, similar to this bike, and this bike, and this bike, and even this bike. We're now in a position to repair and reassemble the engine, but before we do, I'm going to look at some individual components to allow for an arousingly speedy rebuild. The function of the alternator is to generate electrical energy to charge the car battery. Let's take a look at the bearings. Let's change the bearings. The first bearing was willing, but the second one is obstinate and insists on being removed in installments. Okay, so I may have gotten bored and resorted to using the angle grinder. With the bearings removed, a quick repair is needed. The only bolt that sheared during this entire engine disassembly was one crusty alternator bolt. This was the lower bolt, and being the one most exposed to the road, it was in very poor condition to begin with. I didn't want to use too much heat when removing the alternator bolts because of the proximity to the electrical components, and so this one snapped and left a gift behind for me. I've drilled out the remains of the broken bolt from the hole, and I'm now retapping the threads. I'll use the tap and die kit again to clean up any tinware or other threads that may need attention before reassembly. These original Bosch motor brushes have plenty of life left in them and do not need to be changed, so on with the reassembly. Okay, maybe just one more spin. The new bearings fitted, now's a good time to check the armature is still serviceable. No continuity. No continuity. No continuity. No continuity. Continuity! The back plate is sealed to the alternator body with a paper gasket. This gasket is important as it keeps the electrics dry, but both technically and morally I need to replace this item. Now that's how a bearing should sound. It shouldn't. The vapor blasted front panel makes it look like I cheated and just went out and bought a new alternator. From the side, however, it's most definitely the original. I'm not a fan of insulated crimped terminals. They're fine for a temporary repair, but do not give that nice undisturbed factory look. These brass terminals will weather over time and eventually look like they've always been there. There's no point in it looking pretty if it doesn't work. If I get somewhere between 3.5 and 5 ohms, it's a good coil. 4.3 ohms is absolutely perfect. There are many benefits to restoring by repair, not replacement. Doing so keeps carbon in the ground, money in the pocket, and a quality German product on the vehicle. I've tidied up the exhaust we removed previously and have given it a coat of very high temperature paint. On initial application, this type of paint has a soft and powdery consistency, but once the exhaust reaches operating temperature for a sustained period, the paint bakes itself onto the surface. I had the paint and metal polish already on the shelf, so this refurb didn't really cost anything. Finally, I'm going to leak check the air and vacuum system. As the engine draws in air, it creates a vacuum. This vacuum is harnessed to operate certain ancillary systems. A leaky vacuum line is a potential source of the idling problem mentioned in the previous video. I noticed this thermobaric valve was completely blocked. Some degreaser was all that was required to fix this. I'm testing this system by attaching an oxygen line to this valve and attempting to draw air through the tube, which I'm able to do now that the valve is unblocked. The function of this valve is to assist the engine's warm-up cycle. With the engine cold, the valve should be open, allowing engine vacuum to suck on a diaphragm below the air filter, diverting warmer, preheated air into the engine to assist engine warm-up. When the thermobaric valve is warmed by the engine, it should close, meaning no vacuum is available to open the warm air trapdoor, and the engine draws only ambient air to assist cooling. Everything now tests normal. This whole system is in remarkably good condition, and I'm really happy about that, because spare parts are made from unobtainium. We've finally arrived at the point where we can now carry out our engine service and rebuild. But that's for the next episode. Until then, slán go fóill.